Now we're looking at example 2, but before we dive into that from our 1.5 set of notes, we're going to look at some properties with limits as they're going towards positive infinity to negative infinity. Now the beautiful thing about these properties with limits with this infinity is the fact that it behaves basically identical to as if you were approaching a particular number. So if you had those down pretty well, you should be in some pretty good shape for this. Now the limit then, as x goes to some function with maybe a constant in front, pretty much just says that we can likewise pull that constant in front of the limits. So then we end up with c, that constant, times the limit as x goes towards infinity of our function. The sum and difference pretty much just says that we can apply this limit to both items. So we then end up with the limit as x goes towards infinity of f of x, that limit, plus or minus depending on what you're trying to do with your function, the limit as x goes to infinity of our g of x function. And so as a result, you would end up with just some first limit from this guy, and then plus or minus, depending on your operation, some other limit from this guy. Now the third item, oh, by the way, this one we actually did see in example 1, so that's a great reference if you want to check that out. The third one is the product, which again pretty much just says that we can apply this limit to each item, each function. So then we end up with the limit as x goes towards infinity of our f of x function times the limit as x goes towards infinity of our g of x function. And again, this would yield some first limit coming from our f of x function times another limit coming from our g of x function. Next comes the quotient, which pretty much just says that we can go ahead and apply our limit to both items using the quotient. So then we end up then with the limit as x goes to infinity of f of x on top divided by the limit as x goes to infinity of our g of x, which pretty much just says we'll end up with some limit on top, some limit on the bottom, as long as this limit on the bottom is not equal to 0. That'll work. Because again, otherwise it'd be undefined. Using the power property, pretty much just says that we can apply this limit even as it's going towards infinity for the function first and then raise it to whatever power we want. So we end up then with the limit as x goes towards infinity of our function, f of x, applying that limit first and then raising it to whatever exponent we want. So pretty much we'd end up with some limit and then raise it to whatever power we hope for. And the power, I'm sorry, not the power, this should say the nth root. Believe it or not, the nth root is actually a form of the power, so this isn't totally wrong, but it works also for nth roots, so pretty much we can go ahead and apply our limit on the inside here. So then we end up with the limit as x goes towards infinity of f of x. We would take that whole limit first and then apply whatever nth root we want. So pretty much just the nth root of whatever our limit is. Now this does also work for negative infinity, so it's important to keep that in mind that all these operations are equally successful when you try them with negative infinity. Now let's go ahead and use these for example 2. Well, then we end up with the limit as x goes towards infinity of 1 over x raised to the third power. The first one says that we can pretty much use that power property and put our limit on the inside. And so then we end up with the limit as x goes towards infinity of 1 over x raised then to the third power. Now from our notes before, we saw that this actually just came out to be 1 over basically infinity when you apply that limit raised to the third power. Well, 1 over infinity is going to be something incredibly small. In fact, it's going to approach that limit of 0 raised to the third power. And then 0 raised to the third power just comes out to be 0. So that would be our example 2 and some of those properties dealing with limits as they're going towards infinity from our 1.5 number 2 set of notes.